Mechanical and electrical project scheduler, project controller/project scheduler. Who is the project scheduler? When people hear job titles like mechanical and electrical project scheduler, or project controller, they often think all of them mean the same thing, but in reality, these roles are connected while still having important differences, and if you are trying to build a career in planning, scheduling, or project controls, understanding these differences is extremely important because it helps you know what companies are looking for, what skills you need to learn, and which career path is best for you. In this video, we are going to break everything down in very simple words so that even if you are completely new to this field, by the end you will have a clear understanding of who the project scheduler is, what a mechanical and electrical project scheduler does, and how the project controller role is different from both. Now, the reason this topic confuses so many people is because in many companies the job titles are written differently, but the work can sometimes overlap. For example, one company may advertise a role as project scheduler, another may call it planning engineer, another may use project controller or project controls engineer, and in some cases you may even see combined titles like project controller/project scheduler. Then on top of that, some companies also ask specifically for a mechanical and electrical project scheduler, which makes people wonder whether that is a completely different profession or just a specialized version of scheduling. So before going deeper into duties, software, and interview questions, the first thing we need to do is clear up this confusion from the beginning. Let's start with the most basic idea. Every construction project, engineering project, shutdown project, or industrial project has one big challenge, and that challenge is time. A project may have good engineers, good materials, and enough manpower, but if the work is not planned in the correct order and tracked properly, delays begin to happen very quickly. One late activity affects another, procurement gets pushed, inspections get delayed, testing gets affected, and suddenly the whole project completion date is in danger. This is exactly why project scheduling is so important. Scheduling is not just making a list of dates. It is the process of organizing the work, deciding what should happen first, what should happen next, how long each activity will take, and how all activities connect to each other from the beginning of the project until the final handover. This is where the project scheduler comes in. A project scheduler is the person responsible for planning and controlling the project timeline. This person studies the project scope, understands the sequence of work, creates activities, links them together, assigns durations, tracks real progress, and checks whether the project is moving according to plan or falling behind. In simple words, the scheduler is the person who keeps the time side of the project under control. Without a good scheduler, a project team may be working hard every day, but still moving in the wrong direction, because nobody is clearly showing how the work fits together or what impact each delay will have on the final completion date. Now, when we add the words mechanical and electrical before project scheduler, the role becomes more specialized. Instead of planning the full project at a general level, this person focuses mainly on MEP works, meaning mechanical, electrical, and often related systems such as HVAC, plumbing, fire protection, power, lighting, and low current systems. These works are highly technical and usually depend on many approvals, material deliveries, installations, inspections, testing, and commissioning stages. So a mechanical and electrical project scheduler is not just someone who knows scheduling software, but someone who also understands the sequence of mechanical and electrical work in real projects. That is why this role is considered more specialized than a general scheduling role. Then we have the term project controller or project scheduler, and this is where many people become even more confused. A project scheduler mainly focuses on time, progress, activity logic, and completion forecasting, while a project controller usually has a wider responsibility. Project control can include schedule control, progress measurement, reporting, cost tracking, performance analysis, trend monitoring, and management support. In some companies, one person does both jobs, which is why they use a combined title. So when you hear project controller/project scheduler, it often means the company wants someone who can manage the schedule while also supporting broader project control activities, not just updating dates and software. So in this video, we are going to explain all of these roles step by step. We will look at what each title means, what the actual duties are, what skills are required, which software tools are commonly used, how these roles work on real projects, and which one may be better for your career depending on your background. If you come from civil, mechanical, electrical, or MEP works, this topic can help you understand where you fit best. And if you are preparing for jobs, interviews, or career growth in planning and project controls, this understanding can save you from a lot of confusion and help you move in the right direction. So before we move to the next chapter, remember this simple idea. A project scheduler controls time, a mechanical and electrical project scheduler controls the time side of MEP works, and a project controller usually works at a broader level by looking at schedule, progress, reporting, and sometimes cost as well. Once you understand this foundation, the rest becomes much easier. In the next chapter, we will start with the most important question of all: who exactly is the project scheduler, and what does this person really do in a real project environment? A project scheduler is the person who plans, organizes, monitors, and controls the timeline of a project from start to finish, and this role is one of the most important positions in construction, engineering, infrastructure, oil and gas, manufacturing, and many other project-based industries. Because no matter how big or small a project is, someone must make sure the work happens in the right order, at the right time, and in a way that supports the final completion date. Many people think a project scheduler only makes a schedule on software and updates a few dates. But the real role is much bigger than that because the scheduler helps connect planning with execution, meaning this person turns the project scope into a logical, time-based plan that the entire team can follow. To understand the project scheduler clearly, think about a project as a chain of connected activities where one task often depends on another. For example, excavation must happen before foundations, foundations before structure, structure before certain installations, and many MEP and finishing activities can only begin when earlier work is completed or enough access is available. If these relationships are not properly planned, the project team may face confusion, rework, resource clashes, delays, and missed milestones. The project scheduler studies all these dependencies and creates a structured roadmap for the project so everyone knows what should happen, when it should happen, and what effect one delay can have on the next stage of work. At the core of this role, the project scheduler is responsible for building the project timeline in a logical and realistic way. This usually starts by reviewing the project documents such as drawings, scope of work, BOQ, specifications, contract milestones, procurement requirements, and execution strategy. After understanding the project, the scheduler breaks the work into manageable parts, often through a work breakdown structure, or WBS, and then converts that information into a list of activities. Each activity is given a duration and connected to other activities based on logic, because in real projects, tasks do not happen randomly, they happen in sequence. The scheduler's job is to make that sequence clear and workable. One of the most important things a project scheduler does is create the baseline schedule. The baseline schedule is the approved plan that shows how the project is expected to progress under normal conditions. It includes start dates, finish dates, milestones, logic links, and overall project duration. This baseline becomes the main reference point for the entire project because once execution starts, actual performance is measured against it. If site progress is slower than the baseline, then the project may be delayed. If some activities are ahead of plan, that can support recovery or improve project confidence. So the scheduler is not only planning the future but also creating the benchmark used to measure success. The role of a project scheduler does not end after preparing the baseline. In fact, that is only the beginning. Once the project is live, the scheduler continuously updates the schedule based on actual progress from site, engineering, procurement, and subcontractors. This means collecting information about what is started, what is finished, what is delayed, what materials have arrived, which approvals are still pending, and what activities are at risk. Then the scheduler enters this data into the schedule, analyzes its impact, and checks whether the project completion date is still realistic. This regular update process is one of the most valuable parts of project scheduling because it helps management understand the real status of the project instead of relying on assumptions. Another major responsibility of the project scheduler is monitoring the critical path. The critical path is the sequence of activities that directly controls the overall completion date of the project. If one of those activities is delayed, the entire project can be delayed unless corrective action is taken. That is why the scheduler must always know which activities are critical, which ones have float, and where the biggest schedule risks exist. This is not just a technical exercise inside software, it has real project value because it tells the management team where to focus attention, where to allocate resources, and where immediate action is needed to protect milestones. A strong project scheduler also helps the team understand problems before they become serious. For example, if a key material is late, if engineering approvals are delayed, if site access is not available, or if one subcontractor is falling behind, the scheduler can reflect that in the schedule and show its likely impact on future activities. This allows the project team to respond early instead of waiting until the problem becomes impossible to ignore. In that sense, the project scheduler is not only someone who reports progress, but also someone who gives early warning. That early warning function is one of the biggest reasons this role is respected in professional project environments. The project scheduler also plays an important communication role between different departments. The site team focuses on execution, procurement focuses on materials, engineering focuses on design and approvals, and management focuses on milestones and delivery commitments. The scheduler sits in the middle of all of this and connects the information into one timeline. This means the scheduler must coordinate with many people, ask the right questions, verify progress, and make sure the schedule reflects the real project condition. A weak scheduler may only update dates, but a strong scheduler understands that the schedule is a communication tool that helps the whole team work in alignment. Many companies also expect the project scheduler to prepare reports and short-term plans. These may include weekly updates, monthly progress reports, 2-week look-ahead plans, recovery schedules, delay analysis summaries, and milestone tracking reports. These documents help both the internal team and the client understand where the project stands. So the scheduler is not hidden in the background. This role often supports meetings, explains schedule status, highlights concerns, and shows what actions are needed to improve performance. That is why reporting skills, logical thinking, and clear communication are just as important as software knowledge. In simple words, a project scheduler is the person who gives time structure to the project. This role takes a large and complex scope of work and turns it into a clear sequence of planned actions. Then, during execution, the scheduler tracks whether that plan is being achieved and helps the team respond when reality changes. Without a good project scheduler, a project can easily lose direction because nobody is properly connecting activities, monitoring impact, or forecasting the future. But with a strong scheduler, the team gains visibility, control, and a much better chance of finishing on time. So when someone asks who the project scheduler really is, the best answer is this. The project scheduler is the professional who transforms project scope into a time-based execution plan, monitors actual progress against that plan, identifies schedule risks and delays, and supports the team in achieving project milestones and final completion. In the next chapter, we will go deeper into the main duties of a project scheduler and explain exactly what this person does on a day-to-day basis in a real project environment. The main duties of a project scheduler are much broader than many people think, because this role is not only about preparing a program in Primavera P6 or Microsoft project, but about understanding the full project, converting that understanding into a realistic timeline, tracking what is actually happening on site, and helping the project team stay aligned with milestones and deadlines. A strong scheduler is involved from the early planning stage all the way to completion, and the value of this role becomes even more visible when the project starts facing delays, coordination issues, procurement problems, or changing priorities. So in this chapter, we will look at the main duties of a project scheduler in a practical way, step by step, so you can clearly understand what this person actually does in a real working environment. One of the first duties of a project scheduler is to study the project documents carefully before making the schedule. This includes reviewing the scope of work, contract requirements, drawings, specifications, BOQ, project milestones, client deadlines, procurement needs, and sometimes even the construction methodology. This step is extremely important because if the scheduler does not fully understand the project, the schedule will be weak from the beginning. The schedule is only as good as the information behind it, so the scheduler must build a complete picture of what needs to be done, what the major constraints are, and what sequence will make sense in the actual field conditions. After reviewing the project information, the next duty is usually to break the project into manageable sections. This is often done through a work breakdown structure, or WBS, which helps organize the project into phases, zones, disciplines, systems, or deliverables. For example, a building project may be broken into civil works, structural works, architectural finishes, mechanical systems, electrical systems, testing and commissioning, and handover. This structured breakdown allows the scheduler to build the program in a way that is clear, easy to update, and useful for reporting. Without a proper WBS, the schedule may become confusing, difficult to manage, and less valuable to the team. Once the project is structured, the scheduler then defines the activity list. This is one of the core duties of the role because activities are the building blocks of the project schedule. The scheduler decides what tasks need to be included, how detailed the schedule should be, and how each task should be described so it is meaningful to the team. Activities may cover engineering, approvals, procurement, site execution, inspections, testing, and final handover requirements. The scheduler must make sure the list is complete enough to control the project properly, but not so overloaded that the schedule becomes unnecessarily complex and difficult to maintain. After activities are identified, the project scheduler assigns durations to each task. This may sound simple, but it requires judgment, coordination, and experience. Durations must be realistic based on the scope, productivity, manpower availability, procurement lead times, access conditions, and project strategy. If durations are too optimistic, the schedule may look good on paper, but fail in reality. If durations are too conservative, the schedule may not reflect the actual target and could affect project competitiveness or client expectations. So the scheduler must work closely with engineers, site teams, procurement staff, and sometimes subcontractors to estimate reasonable durations that support both realism and project goals. Another major duty is linking activities through logic relationships. This is one of the most important technical parts of scheduling because activities must be connected in the order they will happen in real life. Some tasks must finish before others can start. Some can happen in parallel, and some may require partial completion before the next trait can begin. The scheduler builds these relationships so that the schedule reflects the true flow of the project. This logic network is what allows the team to understand dependencies, identify the critical path, and forecast the effect of delays. A schedule without good logic is not a true control tool, it is just a list of dates. The project scheduler is also responsible for creating the baseline schedule, which becomes the official approved plan for the project. This baseline includes the full activity structure, durations, logic, calendars, milestones, and completion targets. Once approved, it is used as the main reference point to measure performance. This means another key duty of the scheduler is to maintain the integrity of that baseline and use it to compare planned progress with actual progress throughout the project lifecycle. The baseline is not just a formality, it is the foundation for monitoring and decision-making. As the project moves into execution, one of the most regular and important duties of the scheduler is updating the schedule with actual progress. This involves collecting progress data from site engineers, supervisors, subcontractors, procurement teams, and other departments. The scheduler records actual start dates, finish dates, percentage completions, remaining durations, and any delays or changes affecting the work. Then the schedule is updated and analyzed to see whether milestones are still achievable. This duty requires both technical skill and strong communication because the scheduler must gather accurate information from different teams and turn it into a reliable status picture. Monitoring the critical path is another central duty of the project scheduler. The critical path represents the chain of activities that directly determines the project completion date. If a critical activity slips, the entire project may slip unless recovery action is taken. The scheduler must always know which activities are critical, which ones have float, and which changes in logic or progress are shifting the project's priorities. This allows management to focus on the most important areas rather than reacting blindly to every issue. In many cases, the scheduler becomes the person who shows the team exactly where the project is most vulnerable from a time perspective. The project scheduler also has the duty of identifying delays and analyzing their impact. Projects rarely move exactly as planned, so delays are part of real project life. Materials may arrive late, engineering approvals may take longer than expected, site access may be restricted, or manpower may be lower than planned. The scheduler must take these issues, reflect them in the schedule, and show how they affect milestones and final completion. This analysis helps the project team move from guesswork to informed decision-making. Instead of saying the project feels delayed, the scheduler can show where the delay started, which activities are affected, and how much time may be lost if no action is taken. When delays occur, the scheduler often helps prepare recovery schedules and mitigation plans. This does not mean the scheduler alone solves the problem, but the scheduler plays an important role in showing the team possible recovery options. These may include resequencing work, increasing manpower, working in parallel where possible, accelerating procurement, extending working hours, or focusing resources on critical areas. The scheduler can model these options in the program and help management compare the effect of different strategies before making decisions. This is why scheduling is not only about reporting the past, it is also about helping shape the future. Another important duty is preparing short-term planning documents such as look-ahead schedules. A master schedule may show the whole project, but site teams often need a shorter and more practical view of what should happen in the coming 2 weeks, 3 weeks, or 1 month. The scheduler prepares these look-ahead plans to support daily and weekly execution. These plans highlight upcoming activities, material needs, inspections, access requirements, manpower priorities, and coordination points. In this way, the scheduler helps connect long-term planning with day-to-day site operations. The project scheduler is also heavily involved in reporting, weekly reports, monthly updates, milestone tracking summaries, critical path reports, delay notices, progress dashboards, and presentation materials often come from the scheduler or are prepared with the scheduler's input. These reports are important for both internal management and external stakeholders such as clients and consultants. A good scheduler does not just send numbers. This person explains what the numbers mean, what has changed since the last update, what the major risks are, and what action should be taken next. Strong reporting makes the schedule useful at management level, not just inside the planning department. Coordination is another major duty that is sometimes underestimated. The scheduler must regularly communicate with site engineers, procurement staff, design teams, subcontractors, project managers, and other stakeholders. This coordination ensures that the schedule reflects the real condition of the project and that upcoming risks are captured early. The scheduler often acts as a bridge between departments by turning many separate pieces of information into one shared timeline. This makes the scheduler an important support role for overall project communication and control. In simple words, the main duties of a project scheduler include understanding the project, building the schedule, updating progress, identifying delays, monitoring the critical path, preparing reports, supporting recovery planning, and helping the team stay focused on the path to completion. This role combines technical skill, logical thinking, communication, and real project awareness. A weak scheduler only creates a file, but a strong scheduler creates visibility, control, and direction for the entire team. In the next chapter, we will move into a more specialized area and explain who the mechanical and electrical project scheduler is, and why this role is especially important in projects with complex MEP systems. A mechanical and electrical project scheduler is a specialized planning professional who focuses on the time planning, sequencing, monitoring, and control of mechanical and electrical works within a project. And this role becomes especially important in large buildings, hospitals, airports, hotels, towers, factories, industrial plants, and infrastructure projects, where MEP systems are complex, highly coordinated, and deeply connected to every major stage of construction. While a general project scheduler may manage the overall master schedule for the whole project, the mechanical and electrical project scheduler goes deeper into the details of HVAC systems, plumbing, fire protection, power distribution, lighting, low-current systems, testing, commissioning, and sometimes specialist packages as well, which means this role requires not only scheduling knowledge but also strong understanding of how MEP work is actually executed in the field. To understand this role properly, we first need to understand what mechanical and electrical works include in real projects. Mechanical works usually cover systems such as HVAC ducting, chilled water piping, plumbing, drainage, firefighting pipes, pumps, equipment installation, and ventilation systems, while electrical works often include cable trays, conduits, cable pulling, panels, transformers, switchgear, lighting, small power, earthing, fire alarm, and low-current systems like data, CCTV, access control, and communication. These works are not simple add-ons to the project. They are critical systems that make the building or facility functional, safe, and ready for operation. Because of that, they must be planned very carefully, especially since many of them pass through walls, ceilings, shafts, service corridors, and equipment rooms that are shared with other trades. The reason a mechanical and electrical project scheduler is different from a general scheduler is that MEP works follow very specific technical sequences and dependencies. For example, duct supports may need to be installed before ductwork, major pipe routing may need to be coordinated before ceiling closure, cable trays may need access before final finishes, equipment foundations may need to be ready before mechanical equipment arrives, and testing and commissioning cannot happen until installation, inspections, power availability, and system integration are complete. In other words, MEP work is not only about installing items one by one, it is about making sure dozens of systems are installed in the right order, in the right spaces, with the right approvals, and in coordination with civil, structural, and architectural progress. One of the main responsibilities of a mechanical and electrical project scheduler is to build a detailed MEP schedule that reflects all the major stages of mechanical and electrical work. This starts with reviewing project documents such as MEP drawings, specifications, BOQ, equipment lists, material requirements, procurement logs, submittal schedules, contract milestones, and execution strategies. After understanding the project, the scheduler breaks the MEP scope into manageable sections, often by system, area, floor, zone, or building block. Then activities are created for approvals, material procurement, shop drawings, installation works, testing, inspections, pre-commissioning, commissioning, and final handover support. This detailed planning is important because MEP works usually include many interdependent tasks that cannot be controlled properly in a very high-level schedule. A major part of this role is sequencing the installation works in a realistic way. MEP systems often compete for the same physical space, which means planning must account for access, routing priority, clearance, and coordination between trades. In a ceiling area, for example, ductwork, piping, cable trays, conduits, insulation, supports, and fire protection systems may all need to be installed before closing the ceiling. If this sequence is not planned carefully, rework, clashes, and delays can happen very easily. The mechanical and electrical project scheduler works closely with engineers and site teams to understand what should be installed first, what can proceed in parallel, and what must wait for another activity to finish. This makes the schedule much more practical and useful to the actual execution team. Procurement is also a very important part of mechanical and electrical scheduling because many MEP systems depend on long lead materials and equipment. Items such as chillers, air handling units, pumps, switchgear, panels, generators, transformers, control systems, and fire alarm components often require submittals, approvals, manufacturing time, shipping, delivery, and sometimes even factory inspections before they reach the site. A mechanical and electrical project scheduler must therefore include procurement activities in the schedule and connect them logically with installation and testing activities. If procurement is not integrated properly, the project may appear on track in the construction schedule, while in reality, the site team is waiting for critical items that are still under approval or still being manufactured. Another key responsibility is tracking actual progress of MEP works and comparing it against the plan. This means the scheduler regularly collects information from site engineers, supervisors, subcontractors, QA teams, and procurement departments to understand which materials have arrived, which systems are being installed, what inspections are complete, and where delays are happening. Then the scheduler updates the schedule and analyzes its effect on milestones, float, and final completion. MEP work often becomes more critical in the later stages of the project, especially near testing, commissioning, and handover, so accurate updates are extremely important. A small delay in a major system can easily affect multiple downstream activities, including authority approvals and operational readiness. Testing and commissioning are some of the most important areas in the work of a mechanical and electrical project scheduler because this is where MEP systems move from installation stage to operational stage. These phases require careful planning since they depend on system completion, inspections, energization, flushing, pressure testing, balancing, functional testing, integrated system checks, and client or consultant approvals. In many projects, installation may appear nearly finished, but handover still gets delayed because commissioning activities were not properly planned or coordinated. A skilled mechanical and electrical project scheduler does not leave commissioning for the end as an afterthought. This person plans it from early stages and makes sure all the prerequisites are visible in the schedule. Coordination with other disciplines is another major part of this role. Mechanical and electrical works cannot be planned in isolation because they are deeply linked with civil, structural, and architectural progress. For example, MEP activities may depend on concrete completion, blockwork readiness, shaft access, waterproofing, equipment room handover, ceiling closure dates, and final finishes. If the MEP scheduler only focuses on MEP activities without checking these dependencies, the schedule can become unrealistic. That is why this role requires close communication with the general project scheduler, site engineers, procurement teams, subcontractors, and project management so the MEP program remains aligned with the overall project plan. The mechanical and electrical project scheduler also helps identify delays, risks, and recovery opportunities specifically within the MEP scope. If panel approvals are late, if duct fabrication is behind, if major equipment delivery slips, or if inspections are repeatedly failing, the scheduler reflects these issues in the schedule and shows their likely impact. Then management can use this information to make decisions such as increasing manpower, resequencing areas, prioritizing critical systems, pushing approvals, or revising the recovery strategy. This role is especially valuable in the final stages of a project because MEP performance often becomes the deciding factor for practical completion and handover. In simple words, a mechanical and electrical project scheduler is the planning specialist who controls the timeline of MEP works in a project. This person understands the technical flow of mechanical and electrical systems, integrates procurement with installation, tracks progress in detail, plans testing and commissioning carefully, and helps the team avoid delays caused by poor coordination or unrealistic sequencing. It is a more specialized version of the scheduling role, and in projects with complex building services or industrial systems, it can be one of the most critical planning positions on the team. In the next chapter, we will compare the general project scheduler and the mechanical and electrical project scheduler directly so you can clearly understand where they overlap and where they differ. If you are preparing for a mechanical and electrical project scheduler, or project controller interview, one of the first questions you may hear is, 1. Tell us, who is a project scheduler and what does this person do in a project? A project scheduler is the professional responsible for planning, organizing, developing, updating, and monitoring the timeline of a project from the beginning until completion. This role is very important because every project, whether it is a building, industrial facility, infrastructure job, or shutdown project, needs a proper time-based plan to make sure activities happen in the right order. A project scheduler studies the scope of work, creates the activity list, assigns durations, links activities logically, develops the baseline schedule, tracks actual progress, identifies delays, and helps management understand whether the project is on track or falling behind. In simple words, the project scheduler is the person who gives time structure to the whole project and helps the team move toward completion in a controlled way. 2. What is the difference between a project scheduler and a project controller? The main difference is that a project scheduler mostly focuses on the project timeline, while a project controller usually has a wider responsibility that may include schedule, cost, progress, reporting, and performance analysis. A project scheduler builds and updates the schedule, checks critical path activities, monitors milestones, and highlights delay risks. A project controller may do all of that as well, but in addition, may also review budgets, cost performance, earned value, productivity trends, and management KPIs. So if we explain it simply, the project scheduler is mainly responsible for time control, while the project controller often supports broader project control functions, including time, cost, and progress performance together. 3. Who is a mechanical and electrical project scheduler? A mechanical and electrical project scheduler is a specialized planning professional who focuses specifically on mechanical and electrical works within a project. This includes systems such as HVAC, plumbing, drainage, firefighting, electrical power, lighting, low-current systems, testing, and commissioning. Unlike a general scheduler who may manage the entire master program, the mechanical and electrical project scheduler goes deeper into MEP details and understands the technical sequence of these systems. This role is especially important in projects like hospitals, airports, hotels, towers, and industrial buildings, where MEP scope is large and highly coordinated. The person in this role must not only understand scheduling tools, but also understand how MEP works are installed, inspected, tested, and handed over. 4. Why is scheduling important in a project? Scheduling is important because it helps organize the project in a clear and logical way. Without a schedule, different teams may work without proper coordination, which can lead to confusion, rework, delays, and missed milestones. A good schedule shows what work should happen first, what can happen in parallel, what depends on approvals or procurement, and how all activities connect from start to finish. It also helps project managers plan manpower, resources, access, and material delivery more effectively. Most importantly, scheduling allows the team to identify potential delays early and take corrective action before the problem affects the final completion date. So scheduling is not just a planning exercise, it is one of the main tools for project control and successful delivery. 5. What is a baseline schedule? A baseline schedule is the officially approved project schedule that serves as the reference point for measuring actual progress and performance during execution. It normally includes the full activity list, durations, logic relationships, calendars, milestones, and target completion dates. Once the baseline is approved, it becomes the main standard against which the project is measured. For example, if an activity was planned to finish in June but actually finishes in July, the delay can be identified by comparing actual performance to the baseline. In professional project control, the baseline is extremely important because it gives the team a formal benchmark for tracking status, analyzing delays, preparing reports, and supporting decisions related to recovery or extension of time. 6. What is WBS in project scheduling? WBS stands for Work Breakdown Structure, and it is one of the most important concepts in planning and scheduling. WBS is the method of breaking a project into smaller and more manageable sections so that planning, tracking, and reporting become easier. A project can be broken down by phase, discipline, area, building, floor, system, or deliverable depending on the project type and reporting needs. For example, a building project may be divided into civil works, structural works, architectural finishes, mechanical systems, electrical systems, testing and commissioning, and handover. A good WBS makes the schedule more organized, improves visibility, and allows the project team to control each part of the project more effectively instead of dealing with the entire scope as one large block. 7. What is the critical path? The critical path is the longest sequence of connected activities in the schedule that determines the earliest possible completion date of the project. These activities are called critical because any delay in one of them will directly affect the overall completion unless corrective action is taken. In most projects, monitoring the critical path is one of the most important responsibilities of a scheduler because it tells management where the project is most sensitive from a time perspective. If the team focuses only on non-critical activities while critical work is slipping, the project may still finish late. That is why understanding and monitoring the critical path helps the team prioritize properly, protect milestones, and make better decisions regarding manpower, resources, and recovery actions. 8. How do you prepare a project schedule? I prepare a project schedule by first understanding the full scope of the project in detail. This usually starts with reviewing drawings, BOQ, specifications, contract milestones, client requirements, procurement needs, and the execution strategy. After that, I create the WBS and define the activity list in a structured way. Then I estimate durations with support from engineering, site, and procurement teams, and link activities logically according to the actual sequence of execution. I also include approval activities, long-lead procurement items, inspections, testing, and handover-related milestones where needed. Once the schedule is built, I review it carefully to make sure it is realistic and aligned with project goals before submitting it as the baseline or working program. 9. Which software do you use for scheduling? The main software tools I use for scheduling are Primavera P6, Microsoft Project, and Excel. Primavera P6 is usually my primary planning tool because it is strong for large and complex projects, where detailed logic, baseline tracking, resource review, and critical path analysis are important. Microsoft Project can also be useful, especially in smaller or less complex jobs. Excel is still very important because it supports progress tracking sheets, material logs, look-ahead planning, dashboards, and custom reports. In some organizations, Power BI may also be used to create visual dashboards for management. I believe a good scheduler should not only know software buttons, but also know how to use each tool in a practical way to support real project control. 10. Why is Primavera P6 important for a scheduler? Primavera P6 is important because it is one of the most widely used and respected scheduling tools in the construction, engineering, and project control industry. It is designed to handle large and detailed schedules with thousands of activities, multiple calendars, complex logic relationships, and formal baseline tracking. It helps schedulers monitor the critical path, compare planned versus actual performance, update progress, analyze delays, and generate professional reports. In many companies, Primavera P6 is considered a key skill for planning engineers and schedulers because it provides the level of control needed for major projects. However, knowing Primavera alone is not enough. The scheduler must also understand project execution and logic to use it effectively. 11. How do you update a project schedule? I update a project schedule by collecting actual information from all relevant teams, including site engineers, supervisors, subcontractors, procurement staff, and engineering coordinators. I review what is actually started, what is finished, what is delayed, which materials have arrived, and what constraints are affecting progress. Then I enter actual start dates, actual finish dates, progress percentages, or remaining durations into the schedule depending on the agreed method of updating. After updating the data, I analyze the effect on the critical path, major milestones, and final completion date. Finally, I prepare reports that clearly explain what has changed, what areas are at risk, and what actions may be required to recover or protect the project timeline. 12. What documents do you review before preparing the schedule? Before preparing the schedule, I review all major project documents that influence scope, timing, and execution. These usually include the contract, scope of work, IFC drawings, BOQ, specifications, project milestones, procurement schedules, client requirements, execution methodology, and any planning assumptions available at the time. If the project is already mobilized, I may also review resource plans, subcontractor packages, delivery requirements, and permit or approval processes. Reviewing these documents carefully is essential because a schedule must be based on real project requirements, not assumptions. If key documents are ignored, the program may look complete but fail later because it does not reflect the actual sequence, scope, or constraints of the job. 13. What is look-ahead planning? Look-ahead planning is short-term planning that focuses on upcoming activities in the near future, usually for the next 2 weeks, 3 weeks, or 1 month. While the master schedule gives the overall roadmap of the project, the look-ahead plan gives the site team a more practical view of what must happen next. It highlights upcoming tasks, required materials, manpower needs, access requirements, pending inspections, and coordination issues that need attention immediately. Look-ahead planning is very valuable because it connects long-term planning with day-to-day site execution. It helps teams prepare in advance and reduces the risk of short-term delays caused by missing materials, incomplete approvals, or poor coordination between trades. 14. How do you identify project delays? I identify project delays by comparing actual progress against the approved baseline schedule and checking whether activities are starting or finishing later than planned. I also review critical path changes, slippage in milestone dates, low productivity trends, procurement issues, and engineering approval delays. In many cases, delay identification requires close communication with the site team because the schedule alone may show that an activity is behind, but field discussions explain why it is behind. Delays can come from late drawings, long approval cycles, shortage of manpower, material delivery problems, access restrictions, poor coordination, or design changes. A good scheduler does not only identify that a delay exists, but also traces its cause and evaluates its likely impact on future activities. 15. What do you do when a project falls behind schedule? When a project falls behind schedule, the first thing I do is identify the root cause and understand whether the delay is affecting critical path activities or non-critical work. Then I analyze how the delay impacts milestones, float, interfaces with other disciplines, and the final completion date. After that, I work with the project team to explore recovery options such as resequencing activities, increasing manpower, accelerating procurement, working in parallel where possible, extending shifts, or prioritizing specific areas or systems. My role is not only to report the delay but also to help management understand the schedule impact clearly and support recovery planning with realistic program options. 16. What is a recovery schedule? A recovery schedule is a revised and action-focused schedule prepared when the project has fallen behind the approved plan and needs to regain lost time. Its purpose is to show how the project can move closer to the original target or an updated target through acceleration and better sequencing. A recovery schedule may include increased manpower, additional working hours, resequencing of trades, fast-tracking selected activities, early procurement follow-up, and more focused priority control. It is a practical management tool because it shows not only that the project is delayed, but also what the team plans to do about it. A good recovery schedule should be realistic, measurable, and coordinated with the people who will actually execute the work. 17. How do procurement activities affect the schedule? Procurement activities can affect the project schedule significantly because many construction and MEP tasks depend on approvals, manufacturing, shipping, delivery, and site availability of materials and equipment. If long lead items such as chillers, transformers, pumps, switchgear, or major control systems are delayed, installation activities may be pushed back, and that can affect testing, commissioning, and handover as well. This is why a strong scheduler includes procurement activities directly in the project schedule rather than treating them separately. Procurement is not only a purchasing function, it is a schedule driver. Good integration between procurement and construction planning helps avoid situations where the site is ready to work but critical materials are still under approval or still at the factory stage. 18. Why is coordination important in scheduling? Coordination is important because the project schedule must reflect the real interaction between all departments and disciplines involved in the work. Engineering, procurement, construction, quality, testing, inspection, and handover are all connected, and if one part is not aligned with the others, the schedule may become unrealistic. For example, the site team may be ready to install equipment, but if approvals are pending or the material has not arrived, the activity cannot proceed. Similarly, MEP works may depend on civil readiness and architectural access. Good coordination helps the scheduler build a realistic program, collect accurate progress updates, and identify problems early. Without coordination, the schedule may look perfect in software but fail in actual project conditions. 19. What are the main activities included in an MEP schedule? An MEP schedule usually includes a wide range of activities covering the full life cycle of mechanical and electrical work. These activities often start with submittals, shop drawings, material approvals, and procurement follow-up. Then they move into delivery, storage, installation of supports, ducting, piping, cable trays, conduits, cable pulling, equipment installation, panel and control works, inspections, pressure testing, flushing, balancing, energization, testing, pre-commissioning, commissioning, and final handover support. In complex projects, the schedule may also include authority inspections, integrated testing, specialist systems, and training activities. A well-developed MEP schedule must be detailed enough to control these stages properly, because MEP work often becomes the most sensitive part of the project near completion. 20. What is the role of testing and commissioning in MEP scheduling? Testing and commissioning play a very important role in MEP scheduling because they represent the stage where installed systems are checked, verified, and prepared for operation. These activities usually come toward the later stages of the project, but they cannot be treated as an afterthought because they depend on many earlier conditions being completed properly. For example, systems may require installation completion, inspections, flushing, pressure testing, insulation, power availability, control integration, and documentation readiness before commissioning can begin. If these prerequisites are not planned carefully, the project may face major delays even if installation appears nearly complete. A strong MEP scheduler plans testing and commissioning from early stages and makes sure all dependencies are visible in the schedule. 21. How do you measure project progress? Project progress can be measured in several ways depending on the nature of the project and the reporting requirements. Common methods include physical percentage complete, quantity installed versus total quantity, milestone achievement, weighted activity progress, and earned value methods. In construction and MEP projects, Progress should ideally be based on measurable and agreed criteria rather than rough estimates. For example, pipe installation may be measured by installed meter length, while equipment installation may be measured by milestone completion. I prefer using a method that is transparent, documented, and accepted by the project team so that progress reports remain reliable and do not create misunderstandings with management, consultants, or clients. 22. What reports does a project scheduler usually prepare? A project scheduler usually prepares several important reports that help management and stakeholders understand the status of the project. These may include baseline schedule reports, weekly update reports, monthly progress reports, milestone tracking summaries, look-ahead schedules, critical path analysis reports, recovery schedules, delay impact summaries, and presentation materials for meetings. In some cases, the scheduler may also prepare dashboards showing progress by area, discipline, or package. These reports are important because they convert schedule data into useful information for decision-making. A good scheduler does not only provide dates and percentages but also explains what has changed, where the risks are, and what actions may be needed to keep the project on track. 23. What is earned value in project control? Earned value is a project control method used to measure project performance by comparing planned value, earned value, and actual cost. Planned value represents the work that was supposed to be completed by a certain date. Earned value represents the value of the work actually completed, and actual cost shows how much money has been spent. By comparing these numbers, management can understand whether the project is progressing as planned and whether cost performance is acceptable. Earned value is more common in broader project control roles than in basic scheduling roles, but it is still an important concept because it connects time and cost performance in a structured way and supports better performance analysis. 24. What skills are most important for a project scheduler? The most important skills for a project scheduler include logical thinking, planning ability, understanding of activity sequence, analytical thinking, reporting skill, attention to detail, communication, and software competence. A scheduler must be able to study a large project scope and convert it into a structured and realistic timeline. This requires more than technical software knowledge. It also requires understanding how projects are actually executed in the field. Strong communication is equally important because the scheduler must collect progress data, discuss constraints, explain delays, and present findings to engineers, managers, consultants, and clients. In short, the best schedulers combine technical control with practical project awareness and clear communication. 25. What extra skills are needed for a mechanical and electrical project scheduler? A mechanical and electrical project scheduler needs all the core skills of a general scheduler, but in addition must have stronger technical awareness of MEP systems and their execution sequence. This includes understanding the flow of HVAC, plumbing, firefighting, electrical power, lighting, and low-current installation works, as well as related approvals, procurement, inspections, testing, and commissioning requirements. The person in this role must also understand how MEP works coordinate with civil and architectural activities because poor interface planning can create major delays. In practical terms, an MEP scheduler must be able to speak the language of engineers, supervisors, and subcontractors so the schedule reflects how the work really happens in the field. 26. What makes a good project controller? A good project controller is someone who understands project performance in a broad and practical way. This person should be strong in schedule awareness, progress measurement, reporting, cost understanding, trend analysis, and performance monitoring. A good project controller does not simply prepare numbers and charts. This person explains what those numbers mean, what risks are building up, what trends need attention, and where management action is required. Strong project controllers also know how to connect time and cost information into a clear picture of project health. Their value comes from helping decision-makers see not only where the project stands today, but also where it may be heading if no action is taken. 27. How do you handle changing priorities in a project? I handle changing priorities by first understanding the reason behind the change and then reviewing its impact on the schedule, milestones, and interfaces with other activities. Not every priority change has the same effect, so it is important to analyze whether the change affects critical path work, procurement timing, resource availability, or access to other areas. After evaluating the impact, I update the program if needed and communicate clearly with the relevant stakeholders so everyone understands the revised sequence and timing. The key is to remain flexible without losing control of the schedule structure. A good scheduler supports changing project needs while still protecting the logic and realism of the program. 28. How do you work with site engineers and subcontractors? I work with site engineers and subcontractors through regular communication, progress review, and coordination meetings. Their input is very important because they are directly involved in execution and can provide real information about actual progress, productivity, access issues, material shortages, and upcoming work plans. I use this information to update the schedule accurately and make sure it reflects site reality rather than office assumptions. At the same time, I also share look-ahead plans and priority activities so execution teams understand what is most important from a schedule perspective. This two-way coordination helps improve the quality of progress data and supports better decision-making on the project. 29. How do you prioritize activities in a schedule? I prioritize activities based on their effect on major milestones, final completion, critical path status, float availability, procurement dependencies, site readiness, and interface with other disciplines. Activities that directly affect project completion or important deliverables usually receive the highest attention. For example, if a task is on the critical path and has no float, it must be monitored more closely than a task with time flexibility. In MEP projects, activities related to major equipment installation, power availability, testing, and commissioning often become top priorities because they influence handover readiness. Prioritization is important because not all delays have the same impact, and a scheduler must help the team focus on what matters most. 30. Why should we hire you for this project scheduler or project controller role? You should hire me because I understand that scheduling and project control are not only about software, charts, or reporting, but about helping the project team deliver real results in a controlled and organized way. I can study the scope carefully, build realistic schedules, integrate engineering and procurement with construction, track actual progress accurately, identify delays early, and support recovery planning with practical options. I also understand the importance of communication and coordination, which means I can work effectively with engineers, subcontractors, management, and clients. My goal is not just to update a schedule file, but to provide visibility, control, and support that help the project move successfully toward its milestones and completion. Now, as we come to the final chapter of this video, let's bring everything together in a simple and clear way so that you leave with a full understanding of these roles and their importance in the real project world. Throughout this video, we discuss three closely related but different job titles: Project Scheduler, Mechanical and Electrical Project Scheduler, and Project Controller or Project Scheduler. At first, these titles may sound similar, and that is exactly why many people get confused, especially those who are new to planning, scheduling, or project controls. But once we break them down step by step, the difference becomes much easier to understand. The first and most important role we explained was the project scheduler. A project scheduler is the person who plans and controls the time side of the project. This person studies the scope, prepares the work breakdown structure, creates activity lists, assigns durations, develops logic relationships, prepares the baseline schedule, updates progress, monitors the critical path, identifies delays, and supports the team in completing the project on time. In simple words, the project scheduler is the professional who gives the project a time-based structure and helps everyone understand how the work should move from start to finish. Then we moved into the more specialized role of the mechanical and electrical project scheduler. This role focuses specifically on MEP works, such as HVAC, plumbing, firefighting, electrical power, lighting, low current systems, testing, and commissioning. Unlike a general scheduler, this person needs deeper technical understanding of the sequence and coordination of mechanical and electrical activities. This is especially important in complex projects where MEP systems are a major part of the job and where delays in installation, procurement, testing, or commissioning can directly affect final handover. So while the general project scheduler may see the whole project, the mechanical and electrical project scheduler goes much deeper into the MEP side of execution and control. We also explained the role of the project controller or project scheduler, which is often broader than the scheduling role alone. A project scheduler mainly focuses on time control, while a project controller may be responsible for schedule monitoring, progress measurement, reporting, trend analysis, performance review, and sometimes cost control as well. In some companies, one person handles both responsibilities, which is why the job title may include both terms together. This means that if you see a role called Project Controller/Project Scheduler, the company may be looking for someone who can not only manage the schedule, but also support wider project control functions and management reporting. Another major point we learned in this video is that scheduling is much more than software work. Many people think schedulers only prepare a file in Primavera P6 or update a few dates. But in reality, scheduling is one of the most important control functions in any serious project. A good scheduler must understand the project scope, the execution sequence, procurement lead times, coordination needs, site constraints, milestone priorities, and the effect of delays on the overall completion. In other words, the scheduler is not only a software operator, but a time control professional who helps management make informed decisions. We also discussed the main duties of these roles, including reviewing project documents, preparing the schedule, updating actual progress, monitoring the critical path, preparing reports, supporting look-ahead planning, identifying delays, and helping develop recovery plans. These duties show that the role is active throughout the full project lifecycle, not just during the planning stage. Once the project starts, the scheduler becomes one of the key people who helps the team understand where the project really stands and what action may be needed to stay aligned with the target completion date. For those interested in career growth, this topic is also important because these roles can open strong opportunities in construction, engineering, oil and gas, industrial projects, and infrastructure work. If your background is general construction or civil works, then the project scheduler path may be a strong fit for you. If your background is HVAC, plumbing, electrical, or MEP systems, then becoming a mechanical and electrical project scheduler can be a very valuable specialization. And if you want to move into broader reporting, performance analysis, and time plus cost control, then the project controller path may be the right direction for your long-term career. We also covered interview preparation and looked at important job interview questions and answers for these roles, because understanding the theory is one thing, but being able to explain it professionally in an interview is another. Employers want people who not only understand planning tools, but can also explain baseline schedules, critical path, look-ahead planning, delay analysis, recovery scheduling, procurement impact, testing and commissioning logic, and coordination between departments. So if you truly understand the concepts we covered in this video, you are already building a strong base not only for knowledge but also for job interviews and career development. So if we summarize everything in the simplest possible way, the project scheduler controls the timeline of the project, the mechanical and electrical project scheduler controls the timeline of MEP works in more detail, and the project controller usually works at a broader level by looking at time, progress, reporting, and in many cases cost performance too. These roles are connected, they support each other, and in some companies they may even overlap, but each one has its own focus and value within the project environment. The biggest lesson from this video is that project success does not happen by chance. Good projects need structure, visibility, coordination, and control, and that is exactly where schedulers and project controllers bring value. They help transform a complex scope of work into a manageable plan, turn progress into measurable information, and help teams respond early when problems begin to appear. That is why these roles are respected in professional project organizations and why they are such important career paths for engineers and planners. So with that, we reach the end of this video. I hope this chapter-wise explanation helped you clearly understand who a project scheduler is, what a mechanical and electrical project scheduler does, how the project controller role is different, and how all of these roles fit into the bigger picture of project delivery and control. If you understand these foundations well, you can choose the right direction for your career, prepare better for interviews, and develop the right skills for future growth in planning and project controls.